Okay, let's look at these two last ones. Number 10, John lives in a town with a population of 8,400. A recent survey has shown that the town's future population, P, can be calculated in n years using the function blah, 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 blah. So I'm going to put this into Desmos. First step, 8,400. I don't see it, so I'm going to change my window. I'm going to leave the x-axis, but I'm going to change the y-axis to 0. We're talking about the population decreasing, right? So it's not going to get any bigger than 8,400. I'm going to look at this. I don't see a straight line, and I don't see a min or a max, so this puppy is exponential. And I see that here with this exponent, right? It's not squared. Squared would be quadratic. No exponents would be linear. And so I see an exponent that is not a square. So I know this is exponential just looking at this. So quick, I could just do the easiest part. What's P of 6, right? So I'm going to put in P of 6, and it tells it to me. And look at what it says, round to the nearest whole number. That means I don't want anything after the decimal. So this is 0.07, so this is just going to stay 7441, 7,441. 7. Okay, so now let's look at this. Independent and dependent. What is going to depend on something else here? What are the two relationship? What's the relationship between the two variables? We have two variables we're looking for. It tells us n years, right? And it tells us population P. So we have both of the words right there, population and years. And we have to decide what depends on what. So does the population depend on the years, or does the years depend on the population? Well, as the years go by, the population is going to change, right? So the years, it's going to happen no matter what. It's going to be year 1, year 2, year 3, year 4. The population is going to continue to change based on those years. So we know that the population is dependent on the years. Oh no, I don't want to do that. There we go. Years. Okay, so then if we're looking here, we know that P of n, right? And n is like our x here. So x is years. So at 6 years, the population is going to be 7,441. So when we write that as a sentence, we could say the population will be 7,441 at 6 years. Okay. Let's look at number 11. Mr. Snyder bought a car for $25,000. The car's future value, V, so I'm given one thing, a future value, after X years, I'm given years, so future value and years are my two variables, can be found using this formula. Okay, so what depends on what? Let's look here. Independent is the x-axis, that horizontal axis, right? And I see a time value here. So isn't the amount, the value of the car, going to depend on how old it is? If I go to Kelley Blue Book and I put in my car and say, how much is this worth? Well, they're going to say, how old is it, right? The price is going to depend on the years. So the cost is dependent, right? The future value is dependent on the years. I'm going to go over here. I'm going to plug it in. 25,000. Why did I put 28,000? I hope there are no other mistakes. 0.88. Very good. Okay, and I can't see it again. I got to change the window. I can leave this here, but I want to change the Y value. 0. It started at 25,000. And it's decreasing, so I can use 25,000. I don't see a max or a min. It's not a straight line. It's exponential. Okay, so it's going down, and here I can just plug in. What's V of 4? V of 4 is 14,992. And again, we can round as well. 14,000. I'm running out of time here though, so whoop, wrong one. 14,992. 14,992. So after 4 years, or we could say the car's value is 14,992.